Hi, this is my electric car. It's a 1988 Soleq EVcort. It's based on the Ford Escort, but it's never had a gasoline engine in it. Instead, Soleq bought engineless bodies directly from Ford and installed their electric drivetrain and batteries. But it does have the standard Escort instrument panel. That includes the tachometer, but the tach isn't connected, and anyway, the tach isn't that useful in an EV. What you really want to know is how much power you're using, and since the battery voltage is relatively constant, all you really need is an ammeter measuring the current through the batteries. Now this car already has an ammeter, but it's way down there on the floor, so not very convenient when you're driving. And when you shift into third gear, it's completely occluded by the gear shift. So for the longest time, I've been thinking it'd be really nice if the unused tachometer could function as an ammeter. The car's maximum current is about 400 amps, so that'd be about 1 o'clock on the gauge, which is just about perfect. What a tachometer normally does is take a signal from the ignition coil, which is a series of pulses. There's some rudimentary electronics inside the tach that basically count the number of pulses per second and convert that to a DC voltage, and that goes to a voltmeter for an analog readout of RPM. When I converted the vehicle from lead batteries to lithium, I installed an Orion battery management system, which includes a Hall effect current sensor and provides a 0 to 5 volt analog signal corresponding to the current. So I could try to find some kind of voltage-dependent pulse generator to produce a digitized signal suitable for the tach. In fact, at one time there were such devices designed expressly for EV conversions. But why not just skip the middleman and apply the BMS analog signal directly to the voltmeter in the tach? If the signal has enough power for the meter, you won't need any electronics at all. At most, you might need a simple op-amp to boost the voltage or the current enough to power the meter. But for that, we'll need to take the tach apart and check out its voltmeter. Rather than put my own vehicle out of commission, I got a spare instrument cluster to experiment with. Actually, I got two. One's from a junkyard, the other's from eBay. So let's try taking this one apart. It looks like you just remove these screws. Okay, and I think these nuts should release the tach. So how does this come apart? It looks like there are these two wings on the back half of the housing that clip behind some little hooks on the faceplate. Let's see if we can just pry these loose. Maybe now just work it out side to side. Okay, we're in. And sure enough, here's the analog voltmeter, and there in the back is a circuit board feeding it. Looks like these leads just clip onto two prongs on the board. Okay, let's just check the resistance of the coil in the meter here. So it's 165 ohms. That's pretty reasonable. Let's just try energizing with a battery here. So this is 1.28 volts. Let's see what it does on the meter. So we're getting a pretty good deflection there. That's about 2.7. Okay, so if the deflection is 2.7 at 1.28 volts, that's a deflection of 2.1 per volt. Now we expect a maximum current of about 400 amps, so we'd like the meter to go to at least 500 amps, that is 5 on the meter. So at 2.1 per volt, we'll need to energize the meter with at least 2.37 volts. And since it has a resistance of 165 ohms, that means 14.4 milliamps. Unfortunately, the BMS signal is only rated for a maximum of 10 milliamps. And if you do the calculations, it turns out the voltage coming out of the BMS isn't quite high enough either. So we are going to have an op amp between the BMS and the meter. We could design and build a custom op amp for this, but then I found this ready-made DC coupled amplifier board on eBay based on the AD620 op amp chip. Here are the specs. It takes a power supply of anywhere from 7 to 24 volts, so we'll just use the car's 12-volt supply, which is actually about 14 volts. It has an adjustable zero and an adjustable gain of up to 1,000 times, and it takes an input signal of 100 microvolts to 300 millivolts. The signal from the BMS is higher than that, but we'll just drop it down with some resistors. And it gives an output of up to 7.5 volts, which is plenty enough to drive the meter in the tachometer. So here's the plan. It turns out the signal from the BMS actually has an offset. So when it detects zero current, it gives a signal of 2.5 volts. A current of 600 amps gives a maximum 5-volt signal, and minus 600 amps, which would mean a 600 amp charging current, gives 0 volts. We use resistors to drop the 5-volt maximum 25-fold to 0.2 volts, which is well within the 300 millivolt maximum input of the board. So then the zero signal of 2.5 volts will be dropped to 0.1 volt. We'll try to adjust the board so that that gives 0 output. Then we'll adjust the gain so that the 0.2 volt input gives an output of 2.7 volts, which will drive the meter to 6, indicating a discharge current of 600 amps. Negative currents will send a negative voltage to the meter, but it'll still indicate 0 because it only responds to positive voltage. Okay, so here I'm going to try to adjust this little op amp board to see if I can get the voltage that I want with the input that I expect. So I've got it set up on this mock-up board. For the power supply, this little device here gives you 7.5 volts. I'm adding a 9-volt battery to that. That'll give us about 15 volts, which is close to the 14 volts that I expect in the vehicle. Then for the input voltage, there's also a 1.5 volt source, and I'll put that through this 10K potentiometer. That'll give us the 1 2/10 volt that we want for the input. I don't have much information on this board, only what they give in the ad on eBay. And they tell you that there's a zero potentiometer and a gain potentiometer, but they don't even tell you which is which. So we'll have to just figure that by trial and error. So let's go ahead and turn this on. So this is going to be the input voltage, and up here will be the output voltage. So I'm just going to turn on the 1.5 volt source here and just check here. So turn this up. That can give us a few tenths of a volt. And now let's go ahead and connect the power here. So we're at minus 3.25 volts. Now there's Chinese characters here that I don't know what they mean, of course, but there is an indication on each that turning it to the left increases the voltage. So let's just turn each of these and see what they do, try to figure out which one is the zero. So let's try the top here. Let's turn the input to 0. And that's really not doing anything at all. So I'm guessing that's the gain control. So let's assume then this is the 0. And yeah, turn it to the left, it goes down. Turn it to the right, which is supposed to decrease it. And that makes it go more and more negative. So we want our 0 to be at 0.1 of a volt. So let's adjust this to 0.1. Okay, so we want that to be 0 output. So let's try to adjust the 0 here. Okay, now we want, when this voltage is 0.2, this should be 2.7. So let's turn this up to 0.2. And then adjust this, which has to be the gain. We want it to be 2 points, actually pretty close, 2.3. So turn that to the left, and okay, that increases it. To 2.7. Now let's just go ahead and check the 0 again. So that's supposed to be at 0.1. Oh, it seems it's altered the 0. I didn't expect that, but let's readjust that. Back down to 0. Now back up to 0.2. So now this is off. Okay, so I'm just going to go back and forth here, adjust this level, and then adjust the 0 again. See if we can get it right. Okay, 0. .7. That's about as close as we're going to get. So let's just check then 0. So 0 then should be minus 2.7, 2.69. If we check linear, let's try 0.15. That should be half of 2.7, 1.35. Perfect. And if we go to 0.25, that should be 2.7 plus 1.35, 4.05, right? Oh, so it seems we're really losing some linearity here. It should be 4.05. and it's only 3.78. And if we go up to 0.3, that should be 5.4. And instead it's only 4.09. Of course, this is at the limit of the input of this module. Still, one would hope it would be more linear than that. But if the range we're going to be in is going to be between 0.2 and 0.1 volt, and there it does seem to be pretty linear. So if we go to 0.15, exactly 1.35. Okay, so I've got the tach connected. I've left the voltmeter on to see if the load from the tach is going to affect the output voltage. So let's just turn on the input here, and we're still at 0.1 of a volt. I'm going to connect the power to the board. And we're still zeroed. So let's go up to 0.2. Now we said that should be 6 on the tach, which means 600 amps to the motor once it's in the car. So we're a little low here at 5.5. And remember, this used to be 2.7. Now the load here is taking it down just a bit to 2.64. Well, we'll probably have to tweak this several times again anyway, but let's see if we can bring this up to 6. And take this back to 0.1 to check the 0 again. So it's a little off. Okay, so again, I'll just go back and forth here. Try to get it right at both ends. Okay, that's pretty close. Let's try 0.15, which should be 300. That's right on. Okay, so what happens if you take this down to 0? So the meter is on, still on 0. So a little bit of negative voltage isn't going to do anything. Okay, so I think we've got this adjusted quite well now. Starts out right at 0.1, 0.15. Should be at 3. But at 0.2 it is 6. Seems to be a little bit of hysteresis here. If you come up, it's a little low, but if you come from up here and go down, then it's right on. So is that the voltage or is that the meter? So this is now 1.44. Take this up to 1.44. And it's low, so it just seems to be a little bit of drag, a little bit of physical drag in the meter. But I think we got this, I think we got the board adjusted correctly here. So let's turn this off. Of course, in the vehicle, we'll want to have fixed resistors to step down the signal from the BMS. So looking in my collection, I found two 22K resistors, which were put in parallel, and a 470 ohm for a ratio of about 24.4 to 1. That'll give us very close to the 0.1 to 0.2 volts we need as input to the op amp. Okay, so I've got this wired up now exactly as it would be in the vehicle. Here are the two 22K resistors, the 470 resistor, then that voltage from the 470 resistor going into the input of the op amp, and then coming out of the op amp going directly into the tachometer, and this voltmeter will also read that voltage. And then this voltmeter will read the voltage at the top of the voltage divider. So this would be the voltage then coming out of the BMS going into the system. So let's just turn this on here. Put the power to the op amp. And if we increase this to 2.5, that should be the 0 point on the meter. And so we're pretty much right at 0. And of course, the tachometer is on 0. And then if we go to the other end, the maximum voltage, the maximum voltage coming out of the BMS would be 5 volts, and that's supposed to correspond to 600 amps, or 6 on the meter. Okay, so there we're at 5 and very close to 6 on the meter. Again, there's a little bit of drag on the meter here. And that corresponds to actual voltage of 2.79 volts going into the meter. And then if we take it down halfway to 3.75 volts, that should be exactly 300 amps. And it is. So I think I've got this adjusted correctly. And now it's time to go ahead and wire this up and try it in the vehicle. So the question comes, where to actually mount these resistors? Well, I thought of soldering directly to the board, but these connections are really very, very close together. And I bought these little cables, and this is what I'll use to actually connect everything to the op amp board. And actually the pins, if you press down the little clips there, come out of the plug. So I think what I'll do is solder the 470 resistor between two of these pins, and then it'll just be mounted here on the plug. And then the two 22K resistors, I'll solder between the wire on this cable and the wire on the cable from the BMS. So I'll just go ahead now and set that up. Here I've got the 470 ohm resistor mounted in the plug. And maybe we should just connect this up and go try it in the vehicle. Okay, so before we wire this up, let's just check the voltage coming out of the BMS. It's supposed to be the amperage signal. The BMS is under the seat here. It's a bunch of wires, various signals that I don't want to use, but this white wire here is supposed to be giving a signal for the current through the batteries. Okay, so now I've got the white wire from the BMS hooked to this voltmeter. Let's just turn it on. So with essentially no current flowing, it should be 2.5 volts. It is exactly 2.5 volts. That's good. So let's just rev the engine a little bit. I'm sorry, the motor. And the voltage should go up a few tenths of a volt. But it seems to be going down. Okay, so 600 amps should be 2.5 volts. And then 120 amps should be half a volt. So I think what I'll do is put it in high, ride the clutch a little bit, see if I can get this up to 120 amps. So it does seem to be changing by about half a volt, but it's going in the wrong direction. There is one possibility to explain these reversed current readings, and that is there's an option in the software of the BMS to reverse the polarity of the sensor. And you can see with that little check mark there, I am using that option. If we go to this screen, you can see that if I rev the motor, that's a discharge and it's registering as positive current. But if I look at this 1 to 5 volt signal coming out of it, the voltage goes down as I rev the motor. So it's described as reversing the polarity of the sensor, so you'd think that would affect both this signal and the actual reading in the software here. But they don't explicitly say that. So let's try just unchecking this sensor reversal option. And I'll send that up to the BMS. Okay, now you can see the current is already registering negative, and again, if I rev the motor, it goes more negative. And let's see what it does on this 5 volt signal. It's still going down. So it seems that when it says reverse the sensor, it doesn't reverse the reading as far as the 1 to 5 volt signal. So I think what we can do here is if I physically reverse the current sensor, then this will register positive when there's discharge, and this will also register positive on discharge and then this will work better with the with my new tachometer. So let's try and do that. Okay, so here's the rear battery pack, and right here is the Hall sensor. It's a Hall effect sensor, so totally isolated electrically from the pack, and it's a ring around this cable, which comes from more batteries in the front to the rear battery pack, and it's attached right here. So I have to take this apart. I have to take out this fuse to make sure I don't short anything out, and then wrestle this cable out, turn this around, put it back together. Okay, so we're all back together here, and you can see I did manage to flip the sensor around. I decided to do it off camera so I could concentrate on what I'm doing and not on the video. But let's see what that does. Okay, so we're back in the driver's seat here. You can see that the ignition is on, and if we look at the software, now it's registering positive current, and that's without the sensor polarity reversal. If I rev the motor, it measures more positive current. And let's see what happens to the 5-volt signal here. I'm registering a little high when there's no current, but again, if we rev the motor, clearly increasing the signal voltage instead of decreasing. So that's what we want, and then we're ready to try the tachometer. Okay, so I think we're ready for a test here. Just for the test, I've got the tachometer sticking in the glove compartment there, and it's connected to the output of the op amp. The op amp is powered from the 12-volt supply of the car, and it's connected to the BMS as the input. So we're just going to check the reading on the tach, which is calibrated in hundreds of amps, and see how closely that matches the digital ammeter, which is integrated with the controller and has its own current sensor. Just turn it on here. Let's just try to rev the motor. So it is working at least. Let's see if we can get it up to 150 amps. Again, I'll just ride the clutch here. And I'd say that was pretty close. Okay, so as it turns out, we live on a pretty good hill here. So what I'm going to do is just take it out the driveway, up the hill, back in the driveway, see if we can get this at least over 200 amps here. Okay, here we go. That's 124 on the digital. 257. 248. 205. 191. 267. 127. And I'll just turn around here. So it seems we've got pretty good agreement between our new ammeter and the old digital one. They're never going to match perfectly just because of the different timing of the responses to current changes, but they're certainly pretty close. So I think I'll go ahead and try to mount this in the dash. Okay, I'm in the midst of taking apart the dashboard here so I can mount the tachometer in its proper place. I was worried a little bit about these extra lights here that were installed to monitor the controller, but it turns out that pops right out. It's just a cable connecting it. I managed to get this bezel loose, and I've just about got access to the instrument panel here. Okay, so I've got the bezel off here, just attached with some wires, and so I have access to the instrument panel. And it looks like it comes out with just 4 little screws here. So try to get those out. Okay, I managed to get the instrument panel out. Just involved loosening those 4 screws, and then this speedometer cable. And this is all the electrical connections to the instrument cluster. So now I just have to remount the tachometer and get it connected up. Okay, so now I've got 3 tachometers here. I've taken them all apart. Here's the one we were experimenting with, and of course, just take a battery here. This one works, but there is quite a bit of drag on the needle for some reason. This is the one out of my vehicle, and it's completely dead. And here's a third one from another junkyard instrument cluster. And it works. And as you can see, there's no drag on the meter. At all. So he's the winner, and we'll connect him up then. Now the question comes, where to put this circuit board and how to mount it physically. I could just stick it under the dash somewhere. That would certainly be accessible, but it wouldn't be very well protected. There's actually quite a lot of space in the instrument cluster. You could almost mount it inside the tachometer housing once you got that circuit board out. But then it'd be really inaccessible. You'd have to take the whole thing apart, take the tachometer out, even just to adjust the settings. So I think what I'll do is stick it in here right below this fuel gauge. I think the wires can pretty much hold it in place. As far as connections, I can remove the circuit board, and 2 of those connections, one is a ground, one is a 12 volt plus supply. And of course I need both of those, so I can just run wires to the back of the tachometer and hold them in place with this second set of nuts. And then there's this third connection that used to be the signal from the engine, and I'll use that to bring in the signal from the BMS instead. And then the wire from the op amp to the actual meter, I'll just connect that directly and run it through one of these little notches. And then if we look at the back of the panel, you can see how these terminals are connected to the harness that is basically through the nut. So for the ground connection and the connection to the 12 volt supply, B here is for battery, I guess. We want these to go through to the op amp and the tachometer. But for this connection, there's C is for coil. So this is going to the engine. This is a signal from the engine. And this is connection we want to use for the signal for the BMS. So for that, we just put an insulating washer on here and then a ring terminal. And then that'll go straight through from the BMS to the op amp and just bypass the harness. And I think I'll do the same thing for the temperature gauge and the fuel gauge. That's in case we want to use those later. Fuel gauge could be a state of charge gauge, and temperature gauge could indicate temperature of the batteries potentially. Okay, slight change in plans here. It turns out the back of the tachometer housing sits tight up against the back of the instrument panel, so it'd be really difficult to try to connect any wires there. So instead, everything's going to come through the inside of the enclosure. And there are a few notches here that help position the meter in the enclosure, and I've just made those a little bigger. So all the wires will come out there, and inside here, the actual ground for the meter will clip on right there. And then the signal going to the meter will just come out the side with the other wires. You probably saw that directly to the wire from the board. Okay, so I've managed to get all the wires in, get the meter back in the enclosure. And we check it here. The meter still turns freely and it still works, so just have to make that final connection between the board and the actual meter and then put it back in the panel. Okay, so we're all wired up here and back together. There's the circuit board. It'll just sit there under the fuel gauge. And I decided to add a fuse on the power to the circuit board. 250 milliamps should be plenty, and that'll sit down here. And if I ever need to recalibrate the op amp, I can do that by just taking this faceplate off of the instrument panel, and I don't have to remove the instrument panel from the car to do that. And then looking at the back of the panel here, I've got this connection will bring in the signal from the BMS and insulated from the wiring harness. And then I decided to just wire up the fuel and temperature gauges with a cable, again bypassing the harness just in case I want to connect them later. I won't have to take this out of the vehicle. Okay, I've got the panel with the modified tach reinstalled and powered through the existing connector. And I've got the input connected to a defined voltage source. So we can see here that the meter starts to respond at just about 2.5 volts, which is just what we want. And if I crank it up to 3.75 volts, that should read 300 amps. And it does, so it seems to be pretty well calibrated. But I notice a problem, and that is, if we put the turn signal on, it disturbs the meter reading. And if we put the parking lights on, that's even worse. The reading dips by about 50 amps. So I think we've got a grounding problem here. Of course, the input voltage is referenced to the chassis ground. So when you turn on the parking lights, maybe the backlights in the panel draw enough current to raise the ground connections on the panel a few tenths of a volt above the chassis ground. And that decreases the input voltage seen by the op amp. But let's check that. Okay, so I've taken the face off the instrument panel here. What I'm going to try to do is measure the ground in the instrument panel as seen by the op amp with respect to a chassis ground. So I've jammed this little blue wire into the ground part of the connector to the op amp. And then we're going to measure it on the meter, again with respect to ground. So here's a chassis ground. Here's the ground in the instrument panel. Just turn on the ignition here. And already there's significant voltage. So the instrument panel is a little bit positive with respect to the chassis. And I'll just turn on the lights here. We're reading 25 hundredths of a volt. So that's going to be quite enough to change the signal going into the op amp and make a pretty big difference in the tachometer reading. So in retrospect, I should have run a separate independent ground wire to the tach and the op amp, but I didn't. I really don't want to take the whole panel out again. So the solution was to replace the backlight and the turn signal indicator bulbs with LEDs. The LEDs are at least as bright and they only draw 1/8 as much current, 40 milliamps versus 340 milliamps. So that'll be a lot less current on the ground wire to the panel. And sure enough, here's the dip with the regular bulbs. And then here's the dip with the LEDs. I'd say that's pretty negligible. So now I'll just connect the op amp to the BMS, then we'll give it a try. Okay, now the gauge is reconnected to the BMS and it's sufficiently back together for a test. We'll take the same route up the hill here, but this time I'll start in third gear and try to draw a little more current. So it's clearly working. And we're up to 300. And now we're at the top of the hill. Sorry about all the vibration, but if we just look at some of the split frames here, you can see it still matches the digital gauge pretty closely. And now just a few finishing touches. I found an almost identical font to make some decals, and then used a glue stick to relabel the gauge to amps. I've also routed the wiring to the BMS under the carpet and reattached the bezel, so everything's totally back together. Now just one final test here. And yes, it's still working. So that's my new in-ammeter. It turned out to be a little more complicated than I expected, but it's something I've always wanted to do, and really it should work for any of these conversion EVs that have an analog tachometer. Thanks for watching.